Hello students. So in today's session we are going to learn about some physical trends in the periodic table. So first we have to know about periodicity. What do you mean by periodicity? Periodicity is nothing but the properties of elements changes with their change in their electronic configuration, but the strength repeats itself at a regular intervals, and this repetition of character is called periodicity, and the properties are called periodic properties. Or in a simple manner you can tell the properties which are repeated at regular intervals are called periodic properties, and the phenomena is called, and the study of that is called periodicity. That means, what did you understand? At regular intervals of time. So for example, according to their electronic configuration, if they are same in a group, the valency, okay, the group number itself gives the valency. That means they all belongs to same group, same valency, and either they are metals or non-metals we can find. When you move in a period also, their properties will be repeated one after one at regular intervals, means at certain according to their atomic number. So that is called periodicity. The properties which are repeated at regular intervals are called periodic properties, and the phenomena is called periodicity. So in this we are going to learn so many things. In that, first one is atomic radius. So what do you mean by atom? Atom is the smallest particle of matter, right? So atom only we cannot see. How can we find the radius? It is very difficult to find, isn't it? So with the help of some X-ray diffraction, okay, it is calculated by using X-ray, okay, X-ray and electron diffraction technique, but it is very difficult. Exact value we may not get. So look at here, this is the center of the atom, that is nucleus. From this is the one shell, and this one is another shell. From here to here it is also called radius, and from here to here this is also a radius. So atomic radius. So in a circle, this is the center of the circle. From the center of the circle to the adjacent, okay, outer circumference, this is nothing but radius. In the same way for atom also. From the center of the atom, nucleus will be present. From nucleus to the outermost shell, okay, either this shell or this shell is called radius. Understand, children? So as it is having small size, the atom is having very small size. How much? 1.2 Armstrong, or 1.2 into 10 to the power minus 10 meters. Okay, meter in radius. So what do you mean by atomic radius, children? It is the distance between nucleus and any point in an orbit, or it is the half of the internuclear distance between two atoms. So if we see the atomic radius, it is of three types. Okay, it is of three types. First one is metallic radius. So what do you mean by metallic radius, children? Metallic radius, or it is also known as crystal radius. So look at here, a crystal radius or metallic radius. It is half of the distance between center of the nucleus of two adjacent atoms. We have taken two atoms which are adjacent to each other, that means which are joining to each other. Adjacent atoms in a crystal lattice is called crystal radius or metallic radius. Half of the distance between center of the nucleus, from here to here, okay, is called crystal radius. Or in another word, it is called as, it is half the nuclear distance between two atoms of a metal. It is also known as, it is half the nuclear distance between two atoms of a metal. So that is called metallic radius. And second one comes to covalent radius. What do you mean by covalent radius? So half of the distance between center of the nucleus of two atoms which are connected through a single covalent bond. So covalent bond. So look at here, this is one atom, this is another atom. This is the center of the nucleus, this is the center of the nucleus. Both were joined. Okay. So this one is called covalent radius. This radius is called covalent radius. Half of the distance between center of the nucleus of two atoms which are connected through a single bond is called covalent radius. And third type is van der Waals radius. So here half of the distance between atoms of different molecules molecules which are closely approached to each other. For example, molecules means two atoms should be there. So like this. So when they approach closely to each other, okay, closely to each other, this is called, from here to it is called van der Waals radius. Van der Waals radius. If we see the order of radius, van der Waals radius is greater than crystal radius, greater than covalent radius. Understand, children? Once again I am repeating, three types of radius are there: metallic radius, covalent radius, and van der Waals radius. What do you mean by metallic or crystal radius, children? It is the half of the distance between two center of the nucleus of two adjacent atoms in a crystal lattice is called crystal radius. Covalent radius, half of the distance between center of the nucleus of two atoms which are connected through a single bond, are called covalent radius. Van der Waals radius means when two molecules, half of the distance between atoms of different molecules which are closely approached to each other. Molecules means two atoms should combine, isn't it? When they approach closely to each other, this distance is called van der Waals radius. If we see the order of radius, van der Waals radius is greater than crystal radius is greater than covalent radius. So now what happens to the atomic radius when we move down the group or across a period? So as you come down the group, the atomic size increases, isn't it? So because for a new period, a new shell will be added. So as you move down the group, number of shells will be increased. That means atomic radius also increases. So down the group, what happens? Atomic size increases. That means atomic radius also increases because new shells are added, isn't it? So when we see in the period, so what happens? As you come across from left to right in a period, the atomic size decreases. Look at here, children. So like this. So when you move across a period, the atomic size decreases. So why it decreases? Because nuclear charge is increasing. Why nuclear charge is increasing? As you move from left to right in a period, okay, so in inner shell 2 electrons, outer shell 8 electrons will be there. 6, 7, 8. So now this 8 electrons having more negative charge. If 8 electrons are there in the outer shell, means inside the nucleus number of protons also should be equal to the outer electrons, right? So inside the nuclear charge also increases. That means positively charged protons also will be increased. That means it pulls towards the nucleus, isn't it? So this 8 electrons will be pulled towards the nucleus with high charge. That means there is a chance of decreasing the size. Understand, children? Only inner 2 electrons are there. They cannot block the outer shell. That means these 8 electrons can be easily attracted by the inner nuclear charge. Nuclear charge, that means protons and neutrons. Neutrons are neutrally charged, no charge. But protons are positively charged and electrons are negatively charged. So this and this, number of electrons always equal to number of protons. So what happens when you move from left to right in a period, the atomic size will be decreased. Why it is decreased? Because the nuclear charge is going to be increased. How it is increasing? Because the number of electrons in the outer shell are more. That means more chance of pulling towards the nucleus. More negative charge, more positive charge. What happens? It pulls towards. But when you move down the group from top to bottom, what happens? Number of shells go on increasing. That means the distance between the outer electron and the nucleus, okay, outer electron and the nucleus, the distance will be more. That means less chance of pulling towards the nucleus. But whereas in period, there is a lot of chance. Only the shells will be same, but number of electrons is go on increasing. That means more nuclear charge is present, so the atomic size decreases. That means the same atomic radius also decreases in a period. So look at here example in atomic period 2 and atomic in atoms period 3, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. So see the atomic radius for lithium, it is 152 pm. Okay, and here it is 111. So in a period what is happening, it is gone decreasing. But when you see in a group from top to bottom, lithium, sodium, potassium, rubidium, cesium, see it go on increasing. Why? Because the number of shells will be increased down the group, but where the number of shells will not increase when we move in a period from left to right. Only the number of electrons only will be increased. But whereas in a group, the number of shells will be increased. That means from the center of the nucleus to the outermost shell there is a charge will be present, but distance is more. When distance is more, less chance of attracting towards the nucleus, right? So these are the trends down the group and across the period. Next comes to ionic radius. So before talking about ionic radius, you should know about what you mean by ions. So what do you mean by ions? So look at here children, this is sodium, this is sodium plus. So what is the difference between these two? Here plus charge is there, here no plus charge is there. So this is a normal atom, but whereas this one is ion. That means ions are nothing but an atom which is electrically charged or called ions. What do you mean by ions children? An atom which is electrically charged, they are called ions. For example, magnesium 2 plus, chlorine, Cl and Cl minus. So which one is atom, which one is ion? This one is atom, this one is ion, because it is having some charge over it. So whenever any atom having some charge, that are called ions. Understand children? So when they will become as an ions, whenever an atom loses an electron or gain an electron. Okay, when an atom loses electron or by gaining electron, an atom becomes electrically charged. So it is of two types. Ions are of two types, cations and anions. Cations and anions. So cations are nothing but which donate the electrons. They will be having excess electron, they will donate the electrons. So an atom which donates the electrons becomes cation. An atom which gains the electron, one is donating means another one will automatically gain, isn't it? So an anions are nothing but an atom which gains the electron. Clear children? Ions are of two types, cations and anions. Who are called cations? The atoms which donate the electrons are called cations. The atoms which gains the electrons are called anions. Clear? So look at here children again. What do you mean by ionic radius? The distance between center of the nucleus and the electron cloud of outermost orbit in an ion is called ionic radius. The distance between the center of the nucleus and the electron cloud of outermost orbit in an ion is called as ionic radius. So ions are of two types. We already discussed two types. So first one is cation. So what did I say about cations? These are formed, cations are formed by losing of electron. For example, look at here, this one, a metal which is converted into positively charged. So how it become positively charged? By losing an electron, by losing one electron. Okay, by losing one electron from its atom, it becomes positively charged. So the size of the cation is always less than its parent atom. Why it is less than its parent atom? For example, look at here children, this is sodium, atomic number is 11. Okay, so it becomes as sodium plus, that means it is releasing one electron. That means now it is having only 10 electrons. So the number of electrons are decreasing or not? Because of that, the size of the cation is always less than its parent atom. This is parent atom. So this one is ion. So it is having less or not. So due to that, size of the cation is always less than its parent atom. Increasing of positive charge on ion, then size will be decreased. Increasing of positive charge on ion, then what happened? Then its size decreases. That means, look at here, M positive, M2 positive, M3 positive. So M positive is greater. So M positive is having more size than M plus 2 is having more size than M plus 3. That means increasing of positive charge on ion. So if see here plus, that means 1, here it is 2 plus, here is 3 plus. So positive charge is go on increasing. Then what happened? The size is go on decreases. Then the size decreases. That means which one is having more size or big size? This one is having larger size when compared to this two. Understand? More positive charge on an atom, less size will be present. Understand, children? Next comes to anions. So what do you mean by anions? Anions are nothing but they are formed by gaining of electron. So look at here, this is an atom. By gaining an electron, I said. So it gains one electron. Then it becomes as M minus. Okay. So for example, here chlorine is there. Chlorine atomic number is 17. So when it gains one electron, it becomes chlorine minus. Yes. So here the size of the anion is always greater than its neutral atom or parent atom. So why? Because here in chlorine, before it is 17, after gaining one electron, the chlorine will become 18. Okay, it is having 8 electrons. So by increasing number of electrons, the size also will be increased. Isn't it? That is why the size of the anion is always more than its neutral atom. That means M minus is greater than M. So negative charge increases on atom, then size also increases. So M3 minus is greater than M2 minus is greater than M minus. So if negative charge is go on increasing, the size of an atom also increases. So the order of radius of ions like anion, neutral atom, cation, if we see the order of radius of ions, if you see what happens, anions have larger size than neutral atom. Neutral atom is having larger size than cation. So look at here. This is anion having greater size than neutral atom. Neutral atom having greater size than cation. So now we see the variations in groups and periods. So in groups, from top to bottom, what happens to the ionic radius? The ionic radius will be increased. If we see in the groups, the ionic radius increases. In periods from left to right, the ionic radius decreases. Okay, children, this is ionic radius. In groups increases, ionic radius in periods decreases. Next comes to isoelectronic species. Iso means same, electronic species. Isoelectronic species. What do you mean by isoelectronic species? So in isoelectronic species, what happened in ionic radius? So what do you mean by, first of all, isoelectronic species? We find some atoms and ions which contain same number of electrons. So we call them as isoelectronic species. So some atoms and ions having same number of electrons. So such type of things are called as isoelectronic species. Iso means same, electronic means electron, species means some group of either atoms or ions. So in isoelectronic species, what happens in case of isoelectronic species? Number of protons on nuclear charge increases. Then the radius or size will be decreases. So example I am taking O2 minus, chlorine minus, sodium plus, Mg2 plus. So all are having 10 electrons each. So this all are having 10 electrons, isn't it? So the radii would be different because of their different nuclear charges. So the cation with greater positive charge will have smaller radius because greater the attraction of electrons towards the nucleus. If number of electrons are more in their outermost shell, what happens? Gradually it attracts. Understand? And anions with greater negative charge will have a larger radius. So one example I am going to show now. So look at here, children. The number of electrons, yes, the number of electrons and number of protons. So N3 minus is greater than O2 minus, F minus, Ne, Na plus, Mg2 plus and Al3 plus. So all are having 10 electrons each. That means nitrogen atomic number is 7. 3 minus means it is gaining 3. Here children, this is an example, number of electrons and number of protons. So N3 minus having larger ionic radius when compared to O2 minus and compared to F minus, Ne, okay, this is neutral atom, Na plus, Mg2 plus, Al3 plus. So what is happening here? These all are isoelectronic species. That means same electrons, same number of electrons are present. So number of protons, their atomic number, nitrogen atomic number is 7 and 3 minus, that means 3 electrons were added to the nitrogen. So 7 plus 3, 10. And O2 minus, its atomic number is 8. 2 electrons minus means it has gained 2 electrons. It is an anion, isn't it? So here 2 electrons gained, its atomic, now the number of electrons are 10. So what did I say? Radii would be different because of their different nuclear charge. The cations with greater positive charge will have smaller radius. I said the cations with greater positive charge will have smaller radius. Why? Because greater attraction will be present. Okay, now the number of electrons are less when compared to the atomic number, isn't it? 13, but it has lost 3 electrons, only 10 are there. So these 10 electrons have greater effect over by this nucleus. In nucleus will not change because number of protons will be 13 only, but electrons are less. So more positive charge, less negative charge. Then what happens? It drags or it pulls towards the nucleus. That means there is a chance of decreasing the size. When there is a chance of decreasing the size, the ionic radius will also decreases. Normally before the size will be like this. Next it will be comes towards the nucleus because the nucleus attracts the outer shell because number of electrons are less, isn't it? That means cations having smaller radius, anions are having larger radius. So this is about ionic radius. This is about today's class. Thank you children.